So this is our day 2 for practicing laws of exponents. You have a test coming up this Friday. I have the review. It's already linked in your calendar, but I'm missing the key to it. So I have to make a new one, and I'll get that linked as soon as I can so that you can get ready for your test on Friday. It's going to be all about exponents. So just like last week, we have 3 of these worksheets for today with exponent rules. So we're using or learning 6 rules altogether. And this first one is the negative rule. And I'm going to be talking about this part here first that I'm highlighting. It says when you have a negative exponent, you want to take the reciprocal of the base and the exponent, because you never want a negative exponent in an expression, right? So what you're going to do is realize that no answers ever have negative powers. And the way you fix a negative power is you take your base, whatever it is, you push it to the other side of the fraction, and then you make the exponent positive. So in these examples on your worksheet, we're going to look at A first, so I'm right here. X to the negative 3 equals 1 over x cubed. What's happening, so when I say you want to push it to the other side of the fraction, think about how x to the negative 3, it's really x to the negative 3 over 1. And when I'm saying push the base to the other side, it means you bring it down here and you make the exponent positive. Well, but what's left in top, if you've pushed everything down to the other side, there's a 1 left up there. So that's how you get 1 over x cubed, because you can't just have nothing in the top. Same thing with example C right here. It's 1 over y to the negative 8. And I'm telling you, okay, anytime you see a negative exponent, you want to push the base to the other side. So this time, the base with the negative exponent's in the bottom. So pushing it to the other side means moving it to the top. So then y goes to the top, and change the exponent to positive. And there's nothing left on the bottom, so we put a 1 there, but you don't have to leave it. In the bottom, you don't have to write the 1. In the top you do, but not the bottom. So it's just y to the 8. Now I need some more room to talk about examples B and D, so I'm going to erase that stuff I just wrote. Raise your hand if you need that stuff I just wrote up a little bit longer. Does anybody still need that up? Okay, so I'm going to erase it and do some other stuff right there. This is why I didn't want to do a smart notebook today, because I wanted to use a pencil and actual paper, so I have plenty of room. So now I'm going to talk about example B. X to the negative 5, y to the 2. So only one of the bases has a negative exponent here. The x does, right? The y has a positive power. So you don't have to move the y to the other side of the fraction. So remember, this is really over 1. The only base I have to push to the other side is this one, because it's the only one with a negative exponent. So I'm going to take just this one, just this piece, push it to the other side and make its exponent positive. So x gets pushed to the bottom, its exponent becomes positive, and y squared stays on top because it didn't have to change at all. And then on D, what's happening is that the two things being multiplied, they have the same base. They are both x's. So what we do before we do the negative exponent rule is we add their powers. This is from what we learned on Friday. So we're using two rules right here. The rule from Friday where we said that if you have the same base, you add the exponents. So that means you do x to the negative 4 plus 3, which is x to the negative 1. After you do that, now you apply the negative exponent rule. It's really x to the negative 1 over 1. So you're going to push that base to the bottom, change its exponent to a positive number. But now that I've pushed everything from the top to the bottom, there's nothing left in the top. So I put a 1 there as a placeholder. And then the final answer is just 1 over x, because you don't have to write 1 as a power. It's just understood that it's there. So what I'm going to do now is zoom out so you can see all of the practice problems. And I'm going to give you a little time to work that. And then we'll come back and talk about the answers. So let me zoom out for you. This would have been way better under the projector. Dang it. Dang technology. All right, so there are your problems. I want you to get a little bit better. Okay. Let me try one more time to zoom in. Yeah, I can get all those in there. I know we have that watermark still, but so here's all the problems. There's 12 problems. Take 5 minutes to try those, and then put done in the chat as you finish, please, and then we'll talk about it. All right, I'm going to write the answers up here. And then I'll leave it up for a few moments so that you can check your work. Now, I'm just going to write the answers. What I had intended to show you, if I was going to be able to do under the projector, was like my little steps that I did to get the answer. So if you want to see those at some point, I have them, I'll attach them to the stream announcement. I don't know, did I get your stream announcement up before second period? I don't think I did. But anyway, it'll be up there. So for number 1, you should have you should have 1 over x to the 7. And number 2 is just y, okay, or y to the 1. 3 is b cubed over a to the 8. 4 is 3m4 over n to the 12. 5, they just both flip-flop places and their exponents become positive, so it's y cubed over x to the 6th. On C, only the b had to be moved. The a, the 14 was already positive, so it can stay where it is. So it's b to the 10 over a to the 14. 7 is 4m to the 6th n to the 2. 8 is x squared over y to the 3. I'm sorry, w to the 3, y to the 9. And then number 9 is 12a cubed over a to the 1, or just a. But if you notice, the a cubed over a simplifies. Or actually, let's do this better. This other way I like better. I mean, that way it was fine. But if we were practicing our rules from Friday, you notice that these two have the same base. So you can add their exponents. And -1 plus 3 is 2. And then you're done there. You don't have to flip anything. But on number 10, when you go to add the exponents, like there's my with the x's, right? So you're going to add -3 and -1, so that's -4. And then for y, you add the exponents, because this is one big multiplication problem. So you do 2 and -4, which is -2. But now that both of those things have a negative exponent, you have to flip them. So they'll be on the bottom, x to the 4, y to the 2. And because there's nothing left on top, you use a 1 as a placeholder. And for number 11, there's different ways you can approach this. Here's what I'm going to do. I'm going to move m to the -3 down to the bottom. So that would give me m to the +3 with the m to the 7 that stays there. And then n on the bottom with the -8 gets pushed to the top, and its exponent becomes positive. So n to the +8. And n to the 4 stays up there because it's not negative, so it doesn't have to move. But now that you have the same bases on top, both ends, you add their exponents when you multiply. That's from Friday. And same thing on the bottom. You're multiplying the same bases, the bases m. And when you add the exponents, you get 10. And then 12 is a little bit crazy. So here's what we're going to do to start. I have a fraction times a fraction. I'm not even going to think about flipping the negative exponents just yet, okay? What I'm going to do is just multiply across the top and across the bottom, because that's what you do when you multiply fractions. So I have 2. The a on the right fraction doesn't have a number on it, so it's just 2 because I'm not multiplying by any other number. But when I go multiply the a's together, I'm adding their exponents. And this a on the right really has a 1. When you don't see an exponent, you know it's 1. And what we have to do when we're multiplying the a's is add their exponents, 1 and -5. So 1 plus -5 is -4. And I'll deal with that negative exponent in a minute. But I'm going to do the bottom first. So on the bottom, I'm doing b to the 6 times 4b to the -2. So outside in the front of the b to the 6 is a 1. So I do 1 times 4, which is 4. And then I multiply the b's, which means you add their exponents. So you're adding 6 and -2, and that's -4. And now there's a few things going on. Here's the first thing. 2 over 4 simplifies to 1/2. And then the a has a negative exponent, so it's going to come to the bottom and turn the exponent positive. But the b on the bottom also has a negative exponent, so we have to push it to the top and make its power positive. And we don't have to leave the 1 in our answer. So we can just write it like this. B to the 4 over 2. Wait, I felt like I did. Oh, you know what? I did something wrong. I don't know if anybody caught this or not. But right here, I did the math wrong. Show you. You don't have to erase or change anything if you don't want to. Because maybe you didn't even try this problem and you don't want to erase the work. But if right here, I put that was a -4. And it should have been a +4 because 6 and -2 is +4. So if you didn't do it at all and you wrote down what I have, just leave it because the basic idea is okay. But if you did it correctly, like I did not, this is what it should have looked like. So I'm going to erase what I have to show you how it was supposed to be done. I messed up this one step right here. For those of you who did it correctly, I suppose if you did it correctly, you don't really need to see it anyway. But this should have been 4. So this would have been 1/2, and then a to the 4 on the bottom. To the 4. Let me just point out a few things. So this is called power to a power. So we have power to a power rule and then power of a product rule. So what's going on here is I'm going to try and simplify this and just bring your attention to this right here, this B and this B. So what these are saying is if you have a base with an exponent, so I have x cubed right here. So I have a base with a power, and that power is being raised to a power. What you do there is just multiply those things together. Because what's happening is you have x cubed squared. That means x cubed, which is this, x times x times x, times itself, x times x times x. Well, how many x's is that altogether? 6. Okay. So whenever you have a power to a power, you multiply them together. And then this other b over here, it's still powers to powers, but if you look inside the parentheses, there's more than one thing. There's an x with a power, and there's a y with a power. So you're still going to multiply the powers together, but it's kind of like a distributive property. That 5 on the outside gets distributed to this power and to this power. So it's x to the 10, because that's 2 times 5, and then y to the 20, because that's 4 times 5. So to save us a little bit of time, let's skip the really easy ones and start with do 6 through 12. So do these. So do 6 through 12. I'm probably going to keep y'all into advisory. We don't have a video, but we can finish our lesson. So after these, we have one more worksheet. So a few minutes for 6 through 12, because the first ones were easy, and then we'll talk about it. Bye, Austin. Okay, so if you wanted the answers to the first ones, that's super fast and easy, right? You're just multiplying. So it's x to the 10, a to the 12, y to the 40, 6 to the 42, I'm sorry, 21, I was just making stuff up. 4 to the 6 on number 5, and anytime you have a number base where you can actually do the mathematics on it, I would like for you to do it. So for example, 4 to the 6 is 4,096. But if it was like 4 to the 15, I wouldn't expect you to do that. It's a ridiculous number. So you only have to do the math on mildly ridiculous numbers, not super obnoxious ones. So for number 6, remember the inside is x to the 1. And so that power of 6 on the outside gets distributed to those exponents. So it'll be x to the 6th, y to the 30th. On number 7, that power of 3 gets distributed to the m and to the 6 because there's two different things in there. They both get the power of 3. And so that's 6 to the 1. So when you multiply those powers, it's 6 to the 3. And then m to the 36. And 6 to the 3 is not an obnoxious number. It's just like a super normal number. So we are going to go ahead and calculate that. I think I said go ahead and go ahead. We're going to go ahead and calculate. For number 8, there are 3 things in there, a 2, an a, and a b. They're all going to get that power of 2. So 2 to the 2, a to the 2, b to the 16, and then I want you to actually do the math on 2 squared, which is 4. And then on the bottom row, for number 9, everything in there gets that 7 power. So it's 7 to the 2 times 7, which is 14. M to the 9 times 7, which is 63. And n to the 3 times 7, which is 21. You don't have to calculate 7 to the 14. It's obnoxious. It's too big of a number. For number 10, distributing the power of 10, there are 3 things in the parentheses. There's a 9, and 0 times 10 is 0. There's a j to the 1, and 1 times 10 is 10. And then k to the 8 times 10 is 80. But there's one thing going on here that we talked about on Friday, and that's the 9 to the 0. Anything to the 0 power is 1. So this can just be j to the 10, k to the 80. And then for 11, you've got powers to powers, and then you're going to be multiplying stuff. So it's in that first group, it's 3 to the 9, a to the 72, times the second group where you had that 2 power that went in here and here. So 3 squared b to the 10. And the way you finish off this answer is, you see these 2 things both have a base of 3. So you keep the base the same, which is 3. And you add the exponents. 9 plus 2 is 11. And then you bring the a down and the b down. And you don't have to do 3 to the 11. It's crazy. It's a crazy number. And number 12 works just like number 11. You just have an extra variable inside. So you should have 5 to the 4, x to the 28, y to the 4, times 5 to the 2, x to the 6, y to the 16. And when you multiply the 5 bases together, you add their exponents and get 6. When you add the exponents on the x's, you get 34. And on the y's, you get 20. And you don't have to do 5 to the x. It's not really a bad number, but I'll leave that one up to you. Raise your hand if you need this screen up anymore. Okay, I don't think I saw any hands. So we're going to get through the last page, and then I'll let you go for the day. Sorry about the technology stuff at the beginning, taking up the first part of our lesson. So on this last rule, it's called power of a quotient. And quotient means we're dividing. And so that's why if you look at these problems, there's fractions everywhere, right? That means we're dividing. It says when raising a quotient to a power, distribute the exponent to the numerator and the denominator. So I'm just going to work through a bunch of these for you and then give you a few minutes to do a few of the harder ones. So it's still like the last one where you're distributing the power inside, but to every base inside. So like on number 1, the numerator gets the power and the denominator gets the power. So it's 3 to the 3 or x to the 3. And 3 cubed is easy. It's 3 times 3, which is 9, times another 3, which is 20. On number 2, you've got stuff on top and stuff on bottom. All the stuff that you see there gets raised to the 4th power. So that 4th power distributes to the top and to the bottom. And like on the last rule, a power to a power means you multiply them. You multiply the exponents. So on the top, we have a to the 8th. And on the bottom, we have b to the 12th. On 3, the 2 power outside gets distributed to the top and the bottom. So it's, and you're multiplying. Power to a power means you multiply. So 6 times 2 is 12. And on the bottom is 9 to the 1. And that is 9 squared. So you don't have to do 7 to the 12, but 9 squared is easy. It's 80. On number 4, you have 2 things in the numerator, but everything gets that 4 on it. So we get 4 to the 4 over m to the 20. I'm sorry, not over, times over n to the 4. And 4 to the 4 is 256. Let me see if I can find, I think I'm going to do one where there's bases that are on the top and bottom, and then I'll let you finish the rest on your own. Would you like to see me work number 7 or number 12 before we finish? If you, we're just going to go one more. Would you like 7 or 12? Who's still with me? Yes, okay, thank you. Lauren, put her thumb up. Thanks, Lauren. 12, okay. We're going to look at 12. No, I feel like this has been the most painful math lesson in all of history. Maybe not all of history, but recent history. Okay, so number 12. So number 12 is kind of crazy. What we're going to do is work our way from the inside out, kind of like following order of operations where you do parentheses first. So I'm going to focus on this stuff before I worry about that 3 on the outside, okay? So here's how that's going to look. Everything inside this parentheses gets the 4 exponent. But there's a lot of things. There's an m on top and an n on top. On the bottom, there's a 2 and an m. That's 4 things. So I'm taking 4 things and raising it to the 4th power. So the m cubed to the 4th becomes m to the 12th. The n squared to the 4th becomes n to the 8th. The 2 on the bottom, remember, it has an exponent of 1. And 1 times 4 is 4. And then m to the 4th. And then all of that is to the 3rd power on the outside. You could simplify your m's here if you wanted to. So notice how we have m to the 12th over m to the 4. 4 of those cancel, leaving me m to the 8 on top. Or you could think about m to the 12 minus 4. That was our lesson from Friday. And now you can distribute that 3 to everything inside. So m to the 24, n to the 24, over 2 to the 12. I feel like I did something wrong. I think that's right. I can't both like, I think I did something wrong. No, I think it's right. Okay. That's all we got through today. That's all I need you to put pictures of in your Google Classroom. So for today's assignment. So here are the rest of the answers on the worksheet in case you worked them and want to know. There's also the PDF for this key with my work. I'll put it in your Google Classroom. That's a 6. Oh yeah, we did that one. Okay, there you go.